Section 1.6, Part 2, looking at reflections of graphs. So the first reflection is about the x-axis. It says the graph of y is equal to the opposite of f of x is the graph of y equals f of x reflected about the x-axis. So if we think about an x-axis, right, our x-axis up going left and right, if we had some sort of ordered pair, over here at some value x, up here at some value y, I have this ordered pair xy. If I were to reflect it over that x-axis, I would end up with a point that's down over here. That means that I'm over still at x value, but now instead of being up at positive y, we're down at whatever that negative y value is. So in terms of our reflection about the x-axis, what changes? It's our y value that changes. If I were to look at a reflection about the y-axis, it says y is equal to f of negative x is the graph of y equals f of x reflected about the y-axis. And if you remember when we talked about that f of negative x being the same as that f of x, and we're talking about a y-axis, that was when we had an even type of a function. So in this case, if we were to pick a point, say again, I'm sticking with x comma y, some value over x and some value up y. If we now reflect that about the y-axis, that means that we are going over here, which means that we are no longer at positive x, we're down over here at negative x, and we're still up at the same positive y value. So we now have a negative x comma positive y. So in terms of what's changing when you're doing your reflection, if you're reflecting about the x-axis, the x doesn't change. The y value changes. If you're reflecting about the y-axis, your y value doesn't change. Your x value changes. So the piece that becomes the opposite in terms of those reflections. So let's take a look at an example. A reflection about the y-axis. It says use the graph of f of x is equal to the third root of x to obtain the graph of h of x is equal to the third root of negative x. So now in this case, if we're looking, we have an x that's now becoming a negative x. Is that something that's affecting the inside or the outside? What do I mean by inside and outside? Well, if you go back up here, y was equal to the opposite of the function versus y was equal to the opposite of the x value in terms of the function. All right, notice the difference in where the negative is located. Is it an inside change or an outside change? Well, in this case, it's going to match up with an inside change. And if it's an inside change, that means that we're dealing with going about the y-axis. So an inside change, if you remember, we kind of talked about moving left and right and up and down. Inside, we had to put it inside of our brain, and it shifted it left and right. Inside, right? Again, this is still going to be inside. Where did we have some sort of change? We have some sort of change that's going left and right in terms of that reflection. So inside is always going to change somehow left and right, and outside is always going to change somehow up and down. So just a little kind of relation going on there. So in this case, we are reflecting around the y-axis. So that means obviously if I have this point 0, 0, that's not shifting anywhere. If I have a point that maybe I'm over here at this point, this is going to reflect over to this side. And if I had a point that was down here, it's going to reflect over here. And so my graph is now going to look something like this. This is really not the best example because it kind of looks like it could be a y-axis reflection or an x-axis reflection. The next piece is looking at what happens when we vertically stretch and shrink graphs. So it says let f be a function and c a positive real number. If c is greater than 1, the graph of y is equal to c of f of x is the graph of y equals f of x vertically stretched by multiplying each of its y coordinates by c. So what this is telling us, if c is greater than 1, a number that's greater than 1, it's going to end up stretching the graph. Stretching, and we're talking about vertical stretching, means that we're looking at making it go higher or lower, up and down. The next thing says if 0 is less than c, which is less than 1, meaning that c is a fraction, and just a regular fraction, not an improper fraction, a fraction that falls between 0 and 1, like a 1/2 or a 1/3 or a 3/4. So it says if c falls between 0 and 1, the graph of y equals c of f of x is the graph of y equals f of x vertically shrunk, meaning we're making it smaller, by multiplying each of its y coordinates by the c value. So what happens, the first one has if c is greater than 1, meaning that we had that value that was bigger than 1, it's going to make it grow faster. So if we take our original function, they have this blue function drawn in here. So our original function is that blue function. What they're telling us is if we take and multiply by a c factor, each of these points, if we multiply by c, is going to make it stretch. It's going to get higher faster, or in the case of to the left-hand side of 0, we're dealing with those negatives. So it still makes it a vertical stretch. It just stretches up or it stretches down. The other one talks about when you have that shrink. Now, again, we go back to the kind of that blue function as the original. Our y is equal to f of x is that blue line. And then if we have a value that is in between 0 and 1, that means it's going to shrink it down. It's going to make it smaller or make it smaller. It's going to be half the distance it was from that x-axis, if you want to think of it in terms of that. So stretching, you're getting really big. Shrinking, you're getting small. So for example, it has a vertical shrink of a graph. So it says use a graph of f of x is equal to the absolute value of x to obtain the graph of g of x is equal to, we have 2 times the absolute value of x. So if we have this 2 in the front part here, that's a c value that was greater than 0. And although it says vertically shrinking, I think we're not really shrinking. I think we're stretching in this case. So we might not even look at that in terms of shrinking, vertical shrinking or stretching, I guess. So if we have that 2 is kind of going to act like a slope. So that 2 is really going to be kind of like a slope, meaning it's going to get 2 over 1 for every 1 that we would have. So obviously 0, 0. We are not affecting the origin or the vertex of that absolute value function. But what happens is when I go over to 1, I'm now going to have multiplied by 2. So when I'm at 1, I'm really going to be at 2. If I was at a -1, absolute value of a -1 is 1. 1 times 2 is going to be 2. So what happens here is instead of going kind of up 1 over 1, we're now going to go up 2 over 1 because we now have that 2 in the front. It's going to kind of stretch out there a little bit. So our V shape is now going to kind of look a little bit skinnier in a sense. So we're going to have a graph that looks like that. So the other piece is what happens when we horizontally stretch or shrink. So before we vertically stretched and shrank, so in terms of what happened with our vertical stretches and shrinks, we were talking about what's happening up and down. So again, this is a vertical stretch and, vertical was up and down. Our horizontal is going to have it stretch and shrink inside, right? So now this one says if let f be a function and c a positive real number, it says if c is greater than 1, then the graph of y is equal to f of c of x. Notice the c is now on the inside. And if you remember what we talked about inside, outside is taking that left and right, where the outside was taking it up and down. So if c is greater than 1, it's the graph of y is equal to f of x horizontally shrunk. Now think about this. It shrunk. If c is greater than 1, we think c is greater than 1 is bigger than 1. You would think it's going to get bigger. But in this case, it doesn't get bigger. It shrinks. It gets smaller. Now, where is that at? It's on the inside. Remember I said inside, you have to put it inside your brain and you have to think about it. Things that are happening inside of the function are going to cause a change horizontally, left and right. Things on the outside of the function are going to go up and go down, right? So in this case, we are going to have a horizontal shrunk by dividing each of the x coordinates by c. And then if 0 is less than c, which is less than 1, we know what that means, being a regular fraction, right? Again, we're on the inside of the function. Then in this case, we are going to have a horizontal stretch by dividing each of its x coordinates by that c value. So now what happens left and right, if I take my original function, right, again, that original function is this blue curve, right, our f of x function, that blue curve. What happens now is if we add in the c value, right, c is greater than 1, it's a bigger number, what's going to happen is it's now going to end up shrinking. It's going to go smaller left and right. Same thing holds true when we have our original function. This time they start with this blue function here again, and that's our regular y is equal to f of x. And then what they end up doing is if c is that fraction, right, c again on the inside, it's now going to make it get bigger or stretch out horizontally, left and right this time. So let's try an example. So graphing using a sequence of transformations. It says to use the graph of f of x is equal to x squared to obtain the graph of g of x is equal to 2 times the quantity x minus 1 squared plus 3. Notice that these are both quadratic functions. We have an x squared and then we still have that x minus 1 that's being squared. So we're still going to have the same shape. We're still going to have our u shape, but our u shape is going to transform a little bit. So it says we'll use these, we will graph these transformations in order. So let's figure out what type of transformations we have. We have 3 things that actually have been included into our new function. So if I were to start by breaking down these pieces, we have this 2 that's in the front. Well, if I'm on the outside of the function, right, they're outside of parentheses, that means it's an outside piece. Outside is going to affect the graph going up and down. Since this is a 2 that's being multiplied, this is going to have a vertical stretch of 2. Why is it a stretch? Because it is a number that's greater than 1. What else we have going on is we have this minus 1, and that's on the inside of parentheses. So inside of parentheses, inside, we need to kind of put it in our head and think about it. We're going to go opposite of what we think it should be. So if we have a subtract 1, that means it's going to shift it horizontally to the right 1 because it's opposite of what we think. So we're going to go to the right 1 unit. And then the last piece that we have is that plus 3 on the end. And the plus 3, something that's on the outside of the function, so to speak. Outside is just going to move it, in that case, up or down. And this is going to end up being an up 3. So we have 3 pieces that we are transforming, but how do we know what we do first? Well, if you think in terms of the order of operations is going to tell us the order we should go. Order of operations. And if you think about order of operations, we pretty much start with parentheses. We deal with exponents. We deal with multiplication and division. We deal with addition and subtraction. So we're going to still want to start with anything that's going on inside of our parentheses first. So inside of parentheses, that talks about what's happening left and right. Any sort of changes in regards to left to right, the horizontal change. So our horizontal change that we have, that first thing that we're going to end up doing is taking those points and we're going to move them to the right 1 unit. And then from there, if you think about order of operations, obviously we're dealing with that exponent that's still a squared, meaning that's the type of function that we have. Nothing else is going to transform in regards to that. Sorry, that would have been a right 1 unit. That means the next piece we're going to look at is that multiplication or division. In this case, the multiplication or division we have is going to deal with that vertical stretch of 2. So we're going to do the vertical stretch of a factor 2. That means we're going to take each ordered pair that we have and just multiply that value, that y value, by 2. And then the last piece that we would have would be to deal with the up and down, right? The addition or subtraction part that's at the end there. So the last piece we're going to do is we're going to go up 3. So what I'm going to do is I'm going to take a point and I'm just going to start moving it around. I personally think the easiest point to kind of start with is your vertex in regards to the U shape. If I were to take that 0 value, I'm going to end up moving it to the right 1 unit. And then I'm going to vertical stretch it by a factor of 2. Well, if I have an x value that is if I'm dealing with that value of 0, right, up and down 0, that y value of 0, if I multiply by 2, I'm still going to be at 0. But now from there, we're going to go up 3 units, 1, 2, 3. So that vertex is now going to shift to about here. If I were to take, it's kind of a really terrible color. Maybe I'll go with the pink in regards to changing that. So that means we're going to end up here. And this point here is not really there. There we go. All I was doing was showing you how it was changing. So our vertex ends up going right to the 1, or over right 1 space. If I multiply that by 2, I'm still at 0. 0 times 2 is still 0. And then I'm going to shift it up 3 units. Now maybe I take another point. Maybe I take an ordered pair like an initial 1, 1, right? If I would have started by moving that 1, 1 point. Now if I take that and I shift it to the right 1 space, that means I'm now going to be over 1 space. I'll be about here. And then I'm going to vertical stretch it by 2. Well, my y value right now is at a positive 1. 1 times 2 is just going to take it up to a 2, which means it's going to end up about here now. And then I'm going to shift it up 3 spaces. So I'm going to end up going up, if I'm already at 2, that's going to be 1, 2, 3 spaces. It's going to take it to about here. So far, my half of the U shape I'd have is about here, which means the other half is going to go about there. And my graph's not going to be so perfect because I don't have grid lines to kind of demonstrate it a little bit better. But mainly you're going to take those values and you're just going to start moving them. Move them to the right 1 spot. Vertical stretch by 2 means multiply that y value by 2 and then move it up 3 units. Let's try another one. I do not have this in your notes packet, but I thought it would be helpful to try one more. So the 4 steps in general that we would end up doing is dealing with the horizontal, what's happening left and right, whether that's adding or subtracting, opposite of what you think, or if it's using that horizontal shrink or stretch. Then number 2, shrink or stretch, that would have been more or less like the vertical shrink or stretch, and I guess you could have also included the horizontal in there. Step 3 would be to do any sort of reflection, and that just happens when you have a negative in front of the whole function, and then any sort of vertical shift that you have. So if I were to give you this graph, which has 1, 2, 3, 4, 5 points, and they just gave us that our original function y is equal to f of x, and they want us to go about changing it into y is equal to this negative 1/2 x, or sorry, negative 1/2 of the function of x minus 1 plus 3. Let's start with that horizontal change. Horizontal change means that we're going to look at, we have on the inside, anything that's happening inside. So if I have that minus 1, that minus 1 means that I'm going to take each point and I'm going to move it to the right 1 spot. Then from there, any sort of stretching or shrinking. Well, there's no more inside stretch or shrink, so don't have to worry about that. But I have that 1/2 on the outside, which means I'm going to multiply each of those y values by 1/2, meaning I'm going to take half the distance it is from the x-axis. And then if I have a negative in the front, which I do in this case, it's going to reflect around the x-axis. So it's going to flip to the other side of the x-axis. And then in terms of any sort of vertical, in this case I have a plus 3. That means I would end up moving it up 3. So I'm going to take this point and try to see if I can manipulate this around enough so you can see what I'm doing. All right, so if I were to take this point here, the first thing it tells me to do is make a horizontal, a right shift. So if I'm going to move this over to the right 1 spot, and then I'm going to stretch or shrink by 1/2. Well, right now I'm at a 0. Well, 1/2 of 0 is still 0, which means I'm still where I'm at. Step 3 says to reflect about the x-axis. Well, if I'm on the x-axis, I can't really reflect over the x-axis. But then I have a vertical change of up 3. So that means I'm going to take this point, I'm going to go up 1, 2, 3. Now, I'll take another new point. Let's try another color. If I take this negative 2, 4, all right, again, I'm going to kind of follow through the same process. First thing it tells me to do is move it to the right 1 spot. Then from there, I have a stretch or shrink. Well, in this case, it's a shrink because it's a 1/2. I'm going to take half of the space to the x-axis. So if I'm up at 4, what's half of 4? Half of 4 is 2, so that takes me to here. Then I need to reflect it about the x-axis. Well, right now I'm 2 away from the x-axis. Whoops. And if I'm 2 away from the x-axis, there we go. I'm 2 away from the x-axis. That means my reflection is going to end up being 2 away from the x-axis. And then I need to vertically change it up 3. So this is going to go up 1, 2, 3. If I take a next point says 0, 0. Right? If I take 0, 0, first step, move it to the right, 1. I'm going to stretch it by a half. Well, 0 times a half is still 0. I'm going to reflect around the x-axis. I'm not going anywhere. Vertical, it's going to go up 3. 1, 2, 3. Let's take the next point. Next point. 1, 2, 3, fourth point. All right, horizontal. I'm going to shift it to the right, 1 spot. If I can grab it. Give me a second. I'm going to shift it to the right, 1 spot. I'm going to multiply it by a half. Well, right down now I'm at -2. Half of -2 means I'm going to be at -1. I'm going to reflect it about the x-axis. I'm 1 away from the x-axis, so I'm going to be 1 away from the x-axis. And then I have a vertical shift of 3. So I'm going to go up 1, 2, 3, drop it down. And my last point. My last point, horizontal. We are going to move it to the right, 1 spot. We are going to multiply by half. Half of 0 is still 0. I'm going to reflect it about the x-axis, still stays at 0. And I'm going to have a vertical up 3 shift. So up 1, 2, 3. So now I need to draw in what this whole final line is going to look like. Let me see if I can find a pretty color. We'll do purple. All right. So the first part of my graph, right? The first part of my graph had that parabola shape, which means the first 1, 2, 3 points are going to make a parabola shape. And then my last 3 points, so to speak, make a V shape. So that means, I want to redo that. Sorry, guys. All right. So the first part makes a parabola. The second part's going to make a V. And that is what that whole conglomeration of what you do to do these transformations is. Now, if you're still with me, I'm going to give you one more little piece of advice. Our regular y is equal to f of x changed into y is equal to, here's a bunch of crazy pieces for you. All right, in the very beginning, if you have a negative, then it is going to reflect over the x-axis. Now that f here is just that function of f. That's all that f is. So I'm just going to leave that there. Now what happens on the inside, right? Inside is always going to be opposite of what you think. So inside is always opposite of what you think. Now, if I have that b value, that is where the horizontal stretch or shrink comes in. And remember, it's opposite of what you think. So if 0 is less than b, which is less than 1, meaning it's a fraction, that is where you're going to stretch. And if b is greater than 1, that's where it's going to shrink. This c value is what is going to make it go from left to right. That takes care of all the horizontal left and rights. The things that happen up and down, the number on the front part here, that a, that is where you're going to have a vertical stretch or shrink. A stretch is going to happen when a is greater than 1, and a shrink is going to happen when 0 is less than a, which is less than 1, when that's a fraction. And the other piece that's going to have a vertical shift, this is going to be a vertical up or down. And it's exactly what you think. If it's a plus, you're moving it up, and if it's a minus, you're moving it down. So if you stuck with me for the whole thing, that should be a nice little summary of all of our transformations.